Hey, it's getting really close to 2 hours UTC. And before I forget, I'm going to post the fact that I am live on Twitter. I'm not live on Twitter, but I'm going to tweet that I'm live here. Tweet. So, hey, welcome everybody. It's almost 2 hours UTC. Come on, Kat. Got to get out of the way. Go. There we go. There we go. It's 2 hours UTC. Hey, everybody, welcome to the latest live stream of Astronomy Daily Live. This is a daily conversation, get together with friends and spend an hour or so talking all things astronomy. Astronomy covers pretty much everything. So, as long as we limit it to that, I think we're okay. I think we're all right. So I'm going to just hang here for a little while, let folks wander into the circle. I'll get my live stream going up on my smartphone over here. I've got the chat going up on my Linux machine over here, and my sad old Windows 7 laptop that's about 1,000 years old is running the whole show with my $5 um, webcam and my microphone that barely works at all. I'm glad you can hear me at all. This is really, really nice because you don't get a lot of the reverb that you would if I was using a microphone, that was sort of recording the room. So this way you don't get a lot of reverb. So that's very, very awesome. So huge shout out to today. Happy Pi Day to everyone. Now Tony Darnell over at Deep Astronomy says that he doesn't really understand why people get so excited about Pi Day. Well, Tony, dude, okay. Uh, uh, if you're a math nerd like I am, then Pi Day is a very, very exciting day. And of course, it's silly, but that's the great thing about it, is that it's silly, and uh, there are a few things in life that uh, really make you smile out of just you know delight and joy. And the idea of Pi Day is one of them, because it's one of those what are those called, double entendres, double meanings, right? Because if somebody doesn't understand that it's Pi Day, the mathematical Pi Day, meaning, for those of you who don't know or haven't heard, um, today is March 14th, 314, and the first three digits of the um, irrational number that's called pi is 3.14. So today is March 14th, 314, 314. It's Pi Day, right? But those of you who don't know about the mathematical pi, uh, what conjures up in your head is PIE Day, okay? Pi Day. And, that could be a fruit pie, it could be a meat pie, it could be, uh, it could be a, mud pie, right? But it's Pi Day. So, those of us who understand and know about both of the pies, right? That's that's like double awesome. It's double awesome because we get to think about pi, which is this bizarre, bizarre ratio between the diameter of a circle and its circumference. It's this weird ratio that it just exists. It just exists, and uh, there might be some explanations as to why it exists and all of that, but it's very strange. And the very very interesting thing about the the value of pi, the number pi 3.14159.265 blah 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 blah, is that those numbers continue um, in what appears to be sort of a random sequence, right? Not really repeating. There are some numbers like 1/3, okay, that is like 0.333333333 on um, to infinity. And oh, okay, that's all right. That's interesting to think about. But pi is one of those numbers where the numbers after the decimal point uh, don't don't seem to repeat, and the sequence. If you just look at the actual numbers 14159.265 da 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 da, they seem sort of random. Um, so it's a baffling number that math nerds, and some of you are math nerds, uh, you know, really, really greatly appreciate. And, it just so happens that there's this coincidence once a year where it's March 14th and we all get excited because it's 314. So that's very, very awesome. But we can also imagine pie, Pie, key lime or chocolate or peach or apple or strawberry rhubarb or oh, all right, I'm gonna have to get this cat out of here. Hold on 1 second. There is nothing worse than kitty cooties floating in your hydrogen hydroxide. So, and this kitty loves to try to share, and no, not allowed. Cheers. Yeah, so for us math nerds who understand both of those ideas of pi, uh, yeah, it's like a double awesome day. So yeah, one of my favorite days of the year. Pretty close in uh, in sensation to like Groundhog Day, which I really really like, and there's also another day in March. Uh, it's the 4th of March, otherwise known as March 4th, which is the only day of the year that is also a command. March 4th. March 4th. So, yeah, uh, nothing compares to um, um, equinoxes and solstices, though. And we have an equinox coming up on March 20th at 16:15 UTC, Coordinated Universal Time. So you'll have to figure out what time that is for your local area. For me, I'm in southeastern Arizona, which is always, smartly enough, Mountain Standard Time. And Mountain Standard Time is 7 hours behind Coordinated Universal Time. Always, always. So if the equinox occurs at 16:15 UTC, then I have to subtract 7 hours from that, and that turns out to be 9:15 a.m. in the morning on the 20th. So at 9:15 a.m. on the 20th, I will go outside and I will, glance at the sun and say, well, primarily, thanks for being there. Thanks for being there. Thanks for coming up. Thanks for, doing what you do. And doing it so well and so effortlessly that it's very, very awesome. So yeah, happy Pi Day, and I'm sorry, Tony, that you don't really understand that. It is just supposed to be fun. It's supposed to put a smile on your face, and you know what? You know what? It did. It did, and that is the primary purpose, as far as I'm concerned, about Pi Day, is to bring a smile on to people's face, if only for a moment, right? The people at work were so excited about Pi Day that one of the ladies ran out to the store and bought us all a pie. So yeah, we all had a piece of pie on Pi Day, and I talked about pie in both senses of the word. So I think, and I probably should have checked this out, but I think um, they've they've computed the millionth decimal point of pi, something like that. There is a um, piece of computer code that can do it. It takes a lot of time, even for computers, um, to figure that out. But I think they've um, worked it out to uh, uh, to about 1 million decimal places. Now I know 3.14159265. So I know nine places, eight decimal um, places. That's as far back as I can go. But some people, I seem to recall something else, that somebody else had like the first 1,000 um, memorized, or something like that, and it takes them like an hour or two, to recite it. And you know, look, if somebody can stand up on a stage and, and recite Shakespeare for hours, then somebody can certainly uh, uh, recite, the first 1,000 or two numbers in in pi. So yeah, no problem at all. It's just a memorization thing. But yeah, awesome day. One of my favorites, of course. The other thing that I wanted to, yeah, we had cherry pie. So yeah, um, uh, was I learned the other day that Yerkes Observatory is being planned to be shut down. Now, Yerkes Observatory is over in the Chicago area, if I remember right, Minnesota. We'll look it up here in a second, but it is being planned to be shut down. Okay, now Yerkes Observatory is a historical place. It was at one time the largest telescope in the world. It's a refractor, so it uses a lens in the front of this big long tube, and we'll look at some pictures of it. That lens is 40 inches across, so it's about 1 meter across. It's huge. It's huge. It's massive. Uh, Never been there, probably never will, but um, that is a big that is a big chunk of glass. And being the largest telescope in the world in the day, it made some major contributions to the science of astronomy, and to our general understanding. Yeah, okay. Southern Wisconsin, cool. Hey there, Tom. Glad you could stop in. Um, and well, I feel like a broken record. I feel like a broken record because back in the late 80s or so, um, uh, several of the telescopes up on Mount Lemmon, just north of Tucson, were there were discussions going on about mothballing them. A 40-inch telescope, a 60-inch telescope, reflectors. So these use mirrors, large curved mirrors, and they were essentially going to mothball them. And you know, I really wasn't. Um, uh, I didn't play a big um, part in any of this, but I certainly uh, was sort of there at least. And I thought then, and I definitely think now, that uh, not utilizing a 1 meter telescope has got to be one of the most ridiculous things I've ever heard of. That's crazy. Why why would you ignore something so awesome like that? Okay. It's not the biggest telescope in the world. Okay, maybe it's got some problems, right? Some problems. They were talking about mothballing Palomar Observatory a few years ago, and it's like how can you even think of that? That's a 5 meter mirror. That's a 5 meter telescope. Why would you even consider? Why would you even consider dropping that at all? Luckily enough, um, uh, a thing called um, adaptive optics came on, and I guess I dare say saved Palomar from stupidity. Now I'm wondering why this machine is running so slow. Oh, okay. I don't see anything strange. So yeah, sorry about the jerkiness, but that's life. That is the life of a live streamer. Sometimes it's crap, and sometimes it's uh, not so bad, and sometimes it's okay. So that's about as good as I can get. But I'm going to say pretty much what I said way back when 30 years ago, and it's like don't be stupid and mothball a telescope, a 1 meter telescope. Okay, who cares it's a refractor? Who cares if it's not ideal? Somebody is going to want to use that, and I and it's not going to be just one person. Okay, there are people who would do a lot to get time on that kind of a scope, even if there are limitations in terms of how faint an object you can find. I mean, there's a paper that I just posted in my Discord server, um, talking about this star that now the Yerkes Observatory is not going to be able to see sort of the very dynamic circumstellar disk around this star. It's not going to be able to do that, okay? But this star is magnitude 8, like 8.63, okay? So really, I mean, most likely from that location with a 1 meter telescope, they're going to be able to see this star. This star is apparently very, very active. It's spewing out all kinds of um, debris and stuff, and they've been watching it, right? They've been watching it, and you know, just because a Yerkes observatory can't see the little blobs flying off the star and everything, that star needs to be monitored. It needs to be watched. It needs to be looked at. See what the hell is going on, and you have to watch it at different time scales, right? You have to see what it's doing every second, every minute, every hour, every day, every week, every month. I mean, you need to watch this, and if nobody else wants to, sign me up, okay? Because I will take the time to collect that data, do the analysis, and all that. That's very, very cool. You don't, people, come on. You do not mothball a 1 meter telescope. You just don't. You just don't. It's ridiculous. I don't know any of the circumstances or anything else, but it sounds like I read was it a um, press release or some kind of thing where it's just like, there's no funding, to maintain it. Okay, well, that's the same shit that I heard 30 years ago when they were going to not really close Mount Lemmon, but they were going to shut down several of those scopes. Well, people today, okay, the Mount Lemmon Sky Center, okay, and um, the Catalina Sky Survey, okay, are utilizing those telescopes to find asteroids, okay, and as a bonus, they're looking at the sky a lot, and they're finding all kinds of awesome things, and if they were to mothball those things or tear them down or anything, we would be even more screwed than what we already are. So it's like, come on, people, get a clue, get a clue, keep Yerkes open, and you know, forget about the history, forget about the fact that it's a tourist thing. Okay, that's cute, that's fun, everything else. This is a 1 meter telescope, okay? It should be running every single clear night, just like every other one should. And to hear that a telescope of that class is being mothballed because there's no funding to maintain it, that's BS. That's BS. There's no will to keep it open. By the way, I have in my hand a little artifact that probably isn't going to show up very well on the video. This is a very, very dark blue blob, and I have had this in my possession for very close, if not 30 years. And what this is, yeah, it's showing up pretty well actually on the video. So what this is, a group of students, including myself, um, we were, and as I said, I was absolutely just blown away that telescopes on Mount Lemmon were going to be closing because there's no funding and there's no interest, right? Nobody wanted to observe uh, with them because they were too small. Okay, a 40-inch telescope is too small. Oy vey. Um, so what we did is we got enough people excited that we were like, okay, well, if nobody wants to use it, let's use it, for um, um, student projects, right? And so one of the first things that this scope needed was that the mirror need to be um, needed to be recoated. Um, you know, the mirror itself is glass, right? And it's got this um, concave surface to it that is really smooth. But on top of that, you deposit a layer of like aluminum or ideally um, silver. So what you do is you take the mirror out and you put it in a big, huge vacuum chamber. And inside of that chamber, you vaporize a certain amount of either, as I said, silver or aluminum is usually used because it doesn't tarnish, and it's almost as reflective as silver. I think aluminum. Maybe somebody in the chat can tell me aluminum is like 87%, 93% reflective, or silver is like 97%. Don't quote me on that. Easy enough to look up. Uh, 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 so we had the mirror removed, and it just so happens that at the same time they were putting a coating on. I think they were putting the coating on a 6-foot diameter mirror that um, was going to be used for the VAT telescope that is now up on Mount Graham. And we were like, "Do you have a little extra space? Do you have a little extra space? Because we would like to actually coat this 40-inch as well." Now, the coating on there, I believe, is just a few atoms thick, maybe 3 or 4 or 5 atoms thick. So it's very thin coating. So you don't actually need a lot of like aluminum, um, and but you put it in a vacuum and vaporize the aluminum, and it just sticks right to the glass, and it's very awesome. And so we did that, and just sort of part of the process after they put this very thin layer of aluminum on it, they coat it in this layer of plastic, so it just sort of protects it a little bit while it's being moved. Okay, and so we brought the 40-inch mirror back up to Mount Lemmon and got it in the scope, mounted it in the scope, and then we had to peel off this layer of plastic, and that's it. So I grabbed it, I wadded it up into a ball, and I've had it ever since. So there's a little artifact. Now the 40-inch today, I believe, has been completely refurbished. I don't even know if it's the same mirror, but the 40-inch now is being used. It's being used a lot. It's being used, as I said, to find new asteroids and to do some really awesome science. And now I do not claim that I played any active role in that, but I was involved in sort of the first team that said no way, no way are you going to close a 1 meter telescope. That's that's absurd. That's absurd. So I'm saying exactly the same thing about Yerkes. Okay, this is a 1 meter telescope. People, you do not close a 1 meter telescope. Uh, if it's you know if it's broken, fix it. If it needs a little bit of extra help because it's not as great as it can be, you fix it. You fix it. It's all it takes is the will to do so. It doesn't take a lot of dollars. It doesn't take anything else. It takes will. So there's just no will to keep that open. And so I'm doing my little part in saying, look, people, we've got a 1 meter class telescope here. It doesn't matter that it's a refractor. It doesn't matter that it's hard to use. Oh, come on. We're pretty smart about stuff. We can figure things out. And I I can tell you that there are people who would be willing to sort of put up with anything to have a a chance at a 1 meter telescope. Um, so look, if you guys don't want to run it anymore, let me know. Maybe I'll try to figure out how to do it because you don't mothball that kind of thing. And then on top of that, historical, that's okay. That's all right. That brings in tourism, and that spawns thinking about all things astronomy, and that's a nice thing. And that's a nice thing. Silver versus aluminum is not a flat line and could um, eat an entire episode. Yeah, yeah, yeah. Okay, silver versus aluminum is not a flat line. So yeah, okay. Well, this isn't a meteorite, right? This is a chunk of plastic. And Susan, if you missed the story, you're going to have to watch the first half of the live stream again because I'm not going to tell the story again. But there it is. There it is. But no, this is a dark blue piece of plastic. And that's all I'm going to say because I'm not going to spoil it for you. Oh, look, I've got a piece of dust on my lens. Do you see on my hand there? Okay, look, I'm going to see if I can blow it off. Hold on. Oh, it's still there. Huh, I'm going to have to work on that. I never noticed that because, it's sort of right where, the dark spot on the telescope is. So I never noticed it until now, when I put my hand up. It's like, oh, that's kind of interesting. Huh. It's got to be something on the lens. So yeah, got to keep, the quality of the show really, really high. I can't have dust on the lens. So yeah, there's my um, appeal for Yerkes Observatory to just come on, come on. You've got a 1 meter telescope there, and nobody wants to use it. Oy vey, come on. Turn it back into science. Probably you've relied on tourists and um, nighttime observing nights like what Tom is I'm talking about. Turn it back into a science instrument. Turn it back into what it was. And there's so much that can be done with that size of a scope. Wow. Wow. So yeah, don't mothball it. Don't mothball it. Find a way. Find a way to keep it going. Um, uh, Shmoo, is that what this is called? It's called Shmoo. Okay. All right. Well, this this is a souvenir from past good times. Yep, an artifact, an artifact. And yeah, I actually carry this around in my pocket for at least a few years or so. And yeah, it's a little big to carry around in your pocket, but I did anyway. And yeah, it's really rigid. I mean, if I squeeze it really hard, it it still gives a little bit. And I've tried to imagine ways that I could you know unravel this, because you know this is this actually is a circle with a 40 meter 40-inch diameter. So and it's compressed into about an inch and a half or so diameter here, and maybe about an inch, well, 2 inches, maybe by like an inch or so. So yeah, great artifact there. So yeah, I think the spot is on. Oh, do you think it's like on the CCD itself or the CMOS itself? I don't know. I don't know. I'll have to look at it. Got to do a little bit of maintenance here. So yeah, I think let's actually go over and look at Yerkes Observatory really quick for those of you who uh, who aren't aware of this awesome, beautiful scope. It's sort of the typical scope that people sort of think of when they hear telescope. It's this big, long, big, huge dome, and so I'm just going to Google it here when this thing decides to come up. I'll hide that. See, even Google is into Pi Day. Look at that. What do you mean the 30th anniversary of Pi Day? That's ridiculous. Pi Day has been around since before the beginning of time. I don't know what they're talking about there. Well, not Yerkes, Yerkes Observatory, University of Chicago. That's where I got the idea that it was in Chicago. It's actually run by the University of Chicago, but it's in Wisconsin, Williams Bay, Wisconsin. So let's see. Can we? Are there any pictures here? Go to the image gallery. Uh, oh, come on. See, what these guys need is they need somebody to work on their website. Jeez, it's pretty bad that we can't just get a regular old picture of the telescope. All right, let's go to Wikipedia, because you know what? Come on now. What's so hard about doing this, boys? Let's see. Can we actually get a picture of the telescope? Gee whiz. Here we go. So this here it is in apparently 1897. 1897. So there it is. So yeah, this there's a lens up here in front. It's 40 inches across. So you can sort of imagine that this is a huge. Look at the stairway here. And as you can see, this is just an equatorial mount, right? Just like we were looking at last night. So this axis here points north. This axis points to the celestial um, equator. And so this whole thing here rotates around like this, and then the tube goes back and forth. I think I saw a more modern picture of it here. Let's see. Oh, come on now. Oh, why we have to have so much difficulty with these little websites? Okay, so here it is, 2006. 2006. Okay, so not the greatest shot in the world, but yeah, we can see more detail. So this way, sort of coming out and over our heads, would be pointing north, and then this axis is the declination axis, and the tube itself, the telescope itself, is right ascension. So you can barely see here that there are some numbers here on the side. Those are degrees of declination. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, it goes all the way around. And then probably, I don't know if we can, there are any, oh, actually, is that declination? No, that would be right ascension. Degrees of right ascension, and I don't see a declination numbers here anywhere. But you can see it's a big, long, skinny tube, uh, some kind of instrumentation or something on the back here. That's kind of cool. And you see these? See this ring here? That's that that's actually a hand grip. You can, I mean, what you have to do, um, I don't know if this is still exactly the case, but what you would have to do back in the day, right, is grab onto this thing and yank it around. Yeah. So, you release a clutch from the motors that allow it to track the sky. Um, you know, um, um, so there's a motor in here that turns a worm gear, that turns this big wheel here. And then there's a motor in here that turns the other thing. But you can release the clutches and yank this thing around. Um, and yeah, I don't know what this big square thing is on the front. Could could be a lot of things, but as I said, going from here to here is 1 meter, right? 40 inches. So yeah, pretty amazing. Pretty amazing. Uh, Chat skills fail. Yeah. Sorry, Tom. Yeah, you're gonna have to listen to the story uh, earlier in the live stream. You'll have to go back and listen to it. So there is the current, 2006 Yerkes Observatory telescope. So it's this, big scope. Like, why would you want to mothball something like that? That's ridiculous. Ridiculous. All right. Well, I was going to go over a paper today, but I'm looking at the time, and time always seems to fly. So I think what I'm going to do is I'm going to do another object of the day. Um, let's see. Should we do an NGC or should we do a Messier? I'm sort of inclined to do a Messier because there's a better chance of getting more of a variety with Messier objects. So let's do a Messier object. There's 110 Messier objects up in the sky. Of course, going from 1 to 110. So I'm going to use the website called random.org to choose um, to choose um, our object of the day. Centrifugal governor. Cool. Cool. Okay, so there are two scopes. Tom says there's a 40-inch and a 24, and they want to close both of those. Oy vey, that's just I'm I'm sorry. That's just crazy. That's crazy. If you don't want it, just send it over here. Send it over here, or give me access to it. I will make it go. Okay, I will make it go. You guys ever heard of crowdfunding? Come on. All right, we're going to choose an object of the day, a meze object of the day. So random.org is going to choose for us a number, an integer between 1 and 110, and that'll be our meze object of the day. Okay, drum roll, please. Boing. M64. Ah, okay. M64. I know. See, now I say this every single time. It's like, oh, I know what that one is. I'm pretty sure that this is a galaxy. And I actually want to say that it's the Black Eye galaxy. Now, I haven't been doing very, very well on remembering my Meze objects. But so let's go over to Simbad, okay, which is one of the many astronomical databases. And we are going to look up M64. And as I said, I'm pretty sure about this, but you know, if I'm wrong, I'm wrong. I'm a scientist. So, as far as I'm concerned, being wrong is awesome because that means I get to learn more. So let's see. M64. Uncle Bill says I got it right. Yeah, it's a Seifert galaxy. Know that. But yeah, I think it is known as the Black Eye. Let's go over Tom. Was it Tom that was it Messier Objects.com? Was that it? Was that the site? Remember? Yeah. Okay. So let's go over here and just sort of see because this gives the common names for it too. Yeah. Okay. Messier 64, the Black Eye Galaxy. Yeah. So we can actually click on that too, and it'll probably throw up an interesting picture. This is kind of a neat one to see through a scope. Now, uh, just an alert, okay, just an alert. When you look at M64 through a telescope tonight, okay, it is not going to look anything like this at all. Okay, this is a long exposure image taken with a, a scope that's probably bigger than yours, and with a resolution that is being able to see fine um, detail in here that is also much better than yours. But what you will see through even a scope like mine, which is a Celestron Nexstar 8SE. It's an 8-inch telescope, a 0.2 meter telescope. What you'll see is a little fuzz, and you'll see sort of a dark thing through it. So what this is just a lot of gas and dust, a lot of crap, right? Um, and it's unusual for sure. Um, but yeah, and so when you look at it, you kind of get the idea that okay, it sort of looks like a black eye, right? Because there's a dark thing under sort of the brighter center here, so it looks like a black eye. So very, very cool. Hey, I finally remembered one correctly. It's just unbelievable, unbelievable. Now, of course, in the digital sky survey images, this galaxy, at least the center part is so bright that it's just completely overexposed. You can't see any of the dark at all. So bummer, but that's how it goes. Now a Seyfert galaxy is an active galaxy, and at some point we're going to have to go through. That's actually an interesting uh, um, topic for actually a bunch of different shows. Is just going through the different types of galaxies, because there's just so many different types, but there are families that share um, similar characteristics. So this galaxy is a spiral galaxy. That's what that little S stands for there. SA means that the spiral arms are pretty compact. It's not like an S0 where they're very, very, very tight. SA, you can sort of see some spiral arms, and yeah, if you're looking at this or that, you can definitely tell that there, some spiral arm features there, but it's pretty tight, pretty tight. So yeah, this is up in the constellation Coma Berenices, which is I think this is probably part of the Coma cluster, which is of course in that same area. Uh, yeah, so let's go through this. So it looks like he's moving away from us at about 402 kilometers per second. So, the galaxies that we've seen so far in these objects of the day have been moving 1,000, 2,000, 3,000 kilometers per second. Now this guy is moving pretty close. I don't know why this is scrolling around like that. So does that mean that it's you know more associated with us? I don't know. Uh, Thanks, Uncle Bill, for the screenshots. You're awesome. You're very very awesome. Thanks for all of that. Post as much as you possibly want to. It's all awesome as far as I'm concerned. Visual magnitude, pretty faint, right? 8.5. So you're not going to see that with the naked eye, but you will see it through binoculars in a dark sky, for sure. Through a telescope, oh yeah, yep, for sure. And you can see that as you move into the infrared, it actually gets brighter and brighter and brighter. So that's pretty typical for galaxies. Is that you have a lot of blue stars that are bright, and a lot of red stars that are bright. And depending on what wavelength of light you actually look at these stars, the red stars can look pretty bright after a while. Wow, look at all the different names of M40 of um, um, M64. A lot of infrared sources here. Lots of different names. Lots of different names. Yep, you're exactly right, Uncle Bill. That's one of the first things I try, to clear up with people when they start asking me about telescopes is how much does it magnify, and can I get 500x? And it's like, no, you do not want 500x. What you want is a large field of view, and a large aperture. That's what you want. You want a big bucket, and you want to look at a lot at the same time. If you've got that, you are golden. So very very cool. So thanks, Uncle Bill, for all the pictures. As I said, post those. as much as you want anytime because it's all awesome. But look at all the names of this thing. Isn't it amazing? And wow, so 747 professional papers have been written about this galaxy. 493 of them in the past 20 years. So lots of study. Look at that. There are 8 measurements of its distance, 11 of its velocities. So let's see how far away they think this thing is. That's always interesting because sometimes there's quite a scatter. Yeah. See, there is. It goes from what 4.1 million parsecs all the way up to 17 million parsecs. TF, by the way, is the Tully-Fisher relationship. You can look that up on one of my Discord channels. Um, it's it's just one of the many ways of measuring um, um, distances due to relationships between the brightnesses of things and how they behave. So Tully Fisher is just one of the many ways. Of course, now I'm seeing another one called SBF. I don't know what that is, but it's kind of interesting because there's such a spread here, right? So let's just take the average and say that the average is going to be around maybe 8 million parsecs away. So I'm going to grab my handy dandy calculator, which every good scientist has at hand's reach at any moment. I'm going to say, just on average, there, that it's about 8 million parsecs away. So a parsec is 3.26 light years, and there's a million of those, so that's times 10 to the sixth, 3.26 times 10 to the sixth, and then we're going to multiply that by 8. So it's 8 million parsecs away. So that's 26 million light years away. So it's very much in the neighborhood for sure. So you know the velocity being that low, relatively speaking, that sort of indicates that we and it are sort of moving in the same way. As far as galaxies go, yeah, that's absolutely true. Still have to understand a little bit about these additional tables here. I just need to get into it a little bit more because I don't quite understand what they're showing there. Um, Herschel observation log. So there's a Herschel spacecraft, I think. So yeah, maybe that's what they're talking about. I'm not quite sure. So I'll have to look into that a little bit more. Um, let's go over to NED, the NASA Extragalactic Database, and see if Ned has anything interesting to say about that. Gives the same kind of information. The equatorial coordinates of M64. Let's see, is there anything else interesting here? Again, it's got a bunch of different names. Oh, it's called the Evil Eye Galaxy too. The Evil Eye Galaxy. Humans. Humans and your funny names. Let's see. Classifications, extinction, basic data, velocities. All the velocities. Well, yeah, it's 700 and 400. Yeah, got some homework to do still on figuring out how this thing is moving. Let's see here. I think that's it. So let's look around. Um, always like to look at pictures. Pictures are my favorite things. Some of my favorite things. When it comes to astronomy, I like looking at pictures almost first because, well, you know, they say so much. Along with sad songs, they say so much. So let's zoom out a little bit and just look in the neighborhood here, see if there's anything interesting. I think, as I said, I think this is part of a cluster. Maybe not. I've been wrong before. You can see how bright it is. It's just insanely bright. No wonder Charles Messier was able to find this, a bright fuzzy patch where there's nothing else around. Wow, there's really not much else around. So everything pretty much, I can say this with pretty high confidence, that everything else you're seeing in this picture is part of our galaxy. So all of these stars, everything else here are stars in our galaxy and are actually stars that are pretty nearby us. We can't see too many stars further out, than a couple of thousand light years away. And our galaxy is like 100,000 light years across. So all these stars that we see are relatively close to us. But of course, M64 being a galaxy means that it's outside of our galaxy, far, far away. What did we say? 26 million light years away. So all these stars here are probably, a couple of thousand light years away, where this guy is 26 million light years away. So if we were to go out and look at that tonight and look at it, right? We would be seeing it as it was 26 million years ago. That light has been um, traveling this entire time. And luckily enough, it bounces right into our eyes. So, okay, you're seeing a bunch of galaxies 7 to 8 degrees south of it. So let's zoom out a little bit more. Yeah, it's probably part of the Coma cluster. So let's see. We're just going to move down. I don't know what the scale is here, so let's see. But I've got an RA and a deck up here. So let's see. So this is saying, see, I'm looking at these numbers right here. So that's at plus 21. So you're saying 7 to 8 degrees below that. So I want to go to uh, like plus 14. Okay, so I've got a little ways to go. Let's zoom out one more. So we're just still starting to pick it up there. But let's go down to plus 14. See if Uncle Bill's right. Oh, there's a big, big bright galaxy right there. That is not a star. That must be another Messier object of some sort. That's my guess. So yeah, maybe I'm seeing some other galaxies here. Yeah. Here we go. So here's another fainter galaxy. It looks like a galaxy. Let's zoom in, find out. Nope, that's a star. Yeah. Oh no, but here's some. See, here's wow. These are kind of interesting looking galaxies. These are they've got like bars in them. A bar going across. Wow, that's kind of cool that there's a double one of these. I wonder what those guys' names are. I don't know. We may never know. Easy enough to look up. I'm not gonna take the time tonight. Looks like, oh yeah. See, here's a bunch of galaxies. Yeah, I don't know why I wasn't seeing those before, but yeah, lots of galaxies here. Look at them all these guys. There's a nice spiral over here. So yeah, definitely pretty far south of M64. Now let's see, am I going to be able to find it again? Yeah, I can do that. Where is it? Wasn't it around 19? That's not it. Uh-oh, I'm lost. There it is. Okay, there it is. All right, well, cool. So M64, yeah, definitely an awesome looking uh, galaxy. Let's look at the references really quick. I'm going over time, but I always like to sort of see what professionals are studying about this galaxy. It's like, you know, what makes it so interesting uh, that over 700 papers have been written about this thing. Cosmic flow, stellar population synthesis and star forming clumps and galaxy pairs. What drives galactic magnetism? Interesting. Chandra. Chandra is a um, um, X-ray observatory in orbit around Earth. 34 band geometries. So they looked at, at these things at 34 different wavelengths. Wow, that's serious dedication there. Seyfert galaxies, yeah, we know that it's a Seyfert. It's a photometry of 1 million stars in M31 and 15 other galaxies. Maybe M64 is one of those. These are all really recent, right? 2017, right? 2017. So, you know, 2018, okay? 2018. So M64 is being studied to this day, right? So yeah, I'm definitely not gonna go through all of these, but pretty well studied, I would say. Pretty well studied. Pretty awesome. All right, well, cool. I think I'm gonna stop sharing my screen and come back over here because I noticed that we're over the hour and definitely respect your time. Don't want to take up too much. This is a daily thing, so I don't I don't feel as though I have to pack a lot in, try to, you know, go for hours and hours and hours. Although, you know, when it comes to astronomy, I could certainly talk about it hours and hours and hours. But I won't. I won't. But yeah, I have to do something about that black spot. It actually looks like it's getting worse. So interesting. Well, I'll have to check that out. All right, I'm gonna get out of here for now. I'm glad you could come in. If if you've just chanced upon this channel, surfing the web, um, this is a daily live stream, so make sure to subscribe. This happens every single day at 2 hours UTC. Hit the thumbs up. Um, hit the thumbs down. Paranor yesterday suggested the sideways thumb. I don't know if that's an option, but if it is, I would like to see it for sure. Make some comments if you like. Definitely like that. You can follow me on Twitter. It's at Astro and Music. I don't tweet a lot, but sometimes I get into a mode where I do. So yeah, check those out. I like to tweet at least once or twice a day, at at least, or retweet at at least. So do that. Make sure to share this video with others who you think share a common passion. And all right, I'm going to get out of here for now. We'll break the circle of friends for tonight, and I'll see you again on the spin tomorrow, less than 23 hours from now. All right, you guys, take care, and yeah, I will see you tomorrow. Okay, bye.